It's a base. So the rule says when you're multiplying like bases, keep your base and do what with your exponent? Add them. So a half plus a half is 1 whole. Well, what about if I have the square root of 3 times the square root of 3? What's that going to be? 3, right? This is not a coincidence because the square root of 3 is the equivalent of 3 raised to the half power. Every radical can be written as an exponential, and every exponential can be written as a radical. So what is the rule? This is where you want to start writing down. So our rule is going to be, if I have the nth root of a to the m power, this is the equivalent of a to the m over n, and it goes both ways. So if I have a radical, I can change it into exponential, and if I have exponential, I can change it into a radical. Now, on your test next week, I will ask for all answers to be in radical form. But in order to solve some of the problems, we have to first change it to exponential in order to solve, and then turn it back to a radical. And you'll see as we do more problems what I mean by that. Okay, so what I want us to do is change to exponential form. So if I have the 5th root of x squared, so if I'm going to change this to exponential, it's going to be x raised to the 2 over 5 power. So the denominator is always our index. The numerator is always the exponent on the radicand. Okay, what if I just have the square root of 2? What's the index if there's no index written? 2. And what's the exponent if there's no exponent written? 1. So isn't this the same as 2 raised to the half power? Okay, now I want us to change to radical form. So if I have 3 raised to the 2/3 power. All right, so what does the denominator represent of the exponent? The index, perfect. So this is going to be the cubed root of 3 squared. I'm going to follow the same rule that we followed in our exponent unit. If the exponent is 5 or less, you have to multiply it out. If the exponent is 5 or less, you have to multiply it out. If the exponent is more than 5, you can leave it as exponential. So this is 3 to the 2nd power. Do I need to multiply that out? Yes. So this becomes the cubed root of 9. Yes. Yes. Okay. Now, different directions saying something very similar to what we've been doing. I'm going to write convert to a rational exponent. So that means I'm giving you the radical form and I want you to convert to exponential. That's what this means, convert to a rational exponent. So if I have the 5th root of 4x squared. Can somebody tell me why this is wrong? It is not 4x raised to the 2/5 power. Why is that wrong? Good. Only x has that power of 2. Does the 4 have that power of 2? No. So what you can write is a couple of different things. You can write this as 4x squared raised to the 1/5 power. You can also write this as 4 to the 1/5 and x to the times x to the 2/5. Between the two of these, I don't care. These are both correct. I don't care. It's whatever one you prefer at that point. Yeah.
So isn't 4x squared like 2x squared? So you kind of take that out.
Say, so you're saying,
Like 4x squared equals like 2x squared.
Oh, so you're saying make this into
Like 2x
squared and then
yeah.
raised to the 1/5? Yeah, absolutely. You can do that.
Like 2/5.
You can. We're going to get to where we do things like that. So if we're just writing it as exponential, you can. I wouldn't mark that wrong. You don't have to, but what you're thinking, where your mind is going, is exactly where I want it to go because we're going to be doing manipulating things later on. So very good. Okay, so here I have 7 times the 4th root of a. Is that 7 under the radical? No. So only the a is under the radical. So this means this is going to be 7 times a to the 1/4 power. Is it okay that I don't have parentheses around the a? Is that okay? Absolutely, it's okay because that 1/4 only belongs to the a. What if I have the 4th root of 7a? How would I write that? Ariana? Perfect. In this scenario, are the parentheses important? Absolutely. Could you distribute that 1/4 power to the 7 and to the a? Yeah. Do you have to? No. So now we're going to write in radical form. Five y to the 1/3 power. Who has that exponent of 1/3? Violet? Only the y. So only the y is going under the radical. So this is going to be 5 times the cubed root of y. So here we have x to the 2/5, y to the 1/5. So this is nice because they both have the same denominator. What does that mean if they both have the same denominator? Excellent. They have the same index. And since they have the same index, can they go under the same radical? Yeah. So this is going to be the 5th root of x to the 2nd y. All right, what have I done? Violet? Yeah, they're not the same index anymore. So in order for me to change this to radical, I need to make them the same index. In order for me to change this to one radical, I need to make them the same index. But because they're both, the exponents are written as fractions, I could always create equivalent fractions, right? So what I'm going to do is I'm going to find the common denominator of 5 and 2. What's the common denominator for 5 and 2? 10. So this is going to be x to the 2/10, right? 1/5 is the equivalent of 2/10. And then y to the 5/10. Now, do they have the same index? Yes. So now I can write the 10th root of x to the second, y to the fifth. And that's how we would put it under one radical. You guys try this one. X to the 1/3 times y to the 1/6. All right, who has an answer for me? I lost it. Vivek?
Yeah. The sixth root of x squared y.
Good, the 6th root of x squared y. Anybody need to see me do it? No, we all got it? We're good? Okay. So now, don't go ahead of me here. Let's say I have 81 raised to the 3/4 power. Do we agree 81 is a base here? All right. So anytime you have a numerical base raised to an exponent, what you want to do, if possible, you want to change that base. You want to change that base into some number raised to the denominator of that exponent. Is there a number that I can change 81 to into some base raised to the 4th power that will give us 81? Ariana? Say it one more time. You got it. So if I have 3 to the 4th power, isn't that 81? 3 times 3 times 3 times 3. And now I have 3 to the 4th power raised to the 3/4. Why do you think my goal when I have a numerical base raised to a fractional exponent is to change the base into some number raised to the denominator of that exponent? Ariana? Yeah, so you guys remember, power to a power, don't we multiply? And when you multiply, can't we cross simplify? So when I have 4 times 3/4, we're allowed to cross simplify, so those 4's cancel. So if it's possible, anytime you have a numerical base raised to a fractional exponent, you want to change that base into some number raised to the exponent, to the denominator of the exponent. So here we change this into 3 to the 4th raised to the 3/4. The 4's cancel, so now I'm left with 3 to the 3rd power. Do I have to multiply this out? Yes, 3 to the 3rd power is 27. You got it.
If it was like 3 to the 6, you wouldn't multiply it.
Correct.
So anything below like 5 and
5 and below, you multiply out. So here we have 8 raised to the negative 2/3 power. I know it's negative. I'm going to deal with that negative later on. So I will fix it. We can never leave a negative exponent, so I will fix that later. But before I fix the negative, what do you think I'm going to see? I'm going to ask you if we can do. Holly?
You can like make it into 2 to the 3rd.
You got it. So we want to change this base into something raised to the third power, and that something is 2. So 8 is the equivalent of 2 to the third power, and we're raising it to the negative 2/3. Why am I doing that? So we can cancel what? The 3's. So now I'm just left with 2 to the negative second power, and now I can fix that negative pretty easily. Isn't that just the same as 1 over 2 to the second, which is 1/4? All right, you guys try this one. (27) raised to the negative 5/3 power. Mm-hmm. All right, who has an answer for me? Leo? I got the same. Does anybody need to see me do this? Okay. Can I leave a negative exponent? No. So do we agree this is the same as 1 over x to the 2/3 power to make it positive? What does a fractional exponent represent? What does a fractional exponent represent? It's the same as what? Charlie? A radical. That's the whole purpose of this lesson, right? Going from radical to exponential, exponential to radical. So when you have a fractional exponent, it represents a radical. Are you allowed to leave a radical in the denominator? Never. So are you allowed to leave a fractional exponent in the denominator? Never. I'm going to show you 2 different ways to do this. The first way I'm going to show you is changing this to a radical. If you change this to a radical, this would be 1 over the cubed root of x squared. Do we agree? All right, again, we still can't leave that radical there. And if it was a square root, we would just multiply it by itself. But for a cubed root, can I just multiply it by itself? No. Remember, for a cubed root, we need groups of 3 to eliminate the radical. So right now, I have the cubed root of x squared. So I have 2 x's. How many more x's do I need to make a grouping of 3? 1 more. So I'm not multiplying it by itself. I'm multiplying by whatever it needs to make that grouping of 3. So I'm going to multiply top and bottom by the cubed root of just x. So then we end up with the cubed root of x over what? X, yeah. Wouldn't this be the cubed root of x cubed? Well, what's the cubed root of x cubed? X, that was our whole point of doing that, right? So that's just x. Okay, so that's how I rationalized it using radicals. But you could have rationalized it staying in exponential. I'm going to show you how to do that now. So we know a fractional exponent means a radical. So I don't want a fraction. What do I want that exponent to be so there's no more radical?
A whole number.
A whole number. So now I have 2/3. The closest whole number to 2/3 is 1, right? 1 whole. So when you're multiplying, and we have to multiply, You keep your base and you do what with the exponents when you're multiplying? Keep your base and add your exponents. So 2/3 plus what will give me 3/3? 1/3. So I multiply top and bottom by 1/3, x to the 1/3, I'm sorry. And that's going to give us x to the 1/3 over x to the 2/3 times x to the 1/3 is x to the 3/3, which is just x to the first. Yes. So now I would change this to a radical cubed root of x over x. Do I care if you rationalize using exponential or rationalize using radicals? I don't care. It's whatever you prefer. Okay, you guys try this one. Can you distribute in this exponent? Anybody? Can we? Yes, no, maybe so. Yes. Why? Why are we allowed to distribute it in? Because it's not a binomial. Good. It's not a binomial. It's only multiplication. So I can absolutely distribute in that exponent. And I would recommend to distribute that exponent in and then go from there. Okay, so you should have started with x to the negative 2/4, y to the positive 3/4. Can I simplify 2/4 down to a half, negative a half, negative 2/4? Yeah, but I'm opting not to. Why do you think I'm opting not to change the negative 2/4 to negative a half? Leo? Yeah, so we can keep a common index, right? So that's my plan. Yes. Yes. So now, out of these two variables, which one is the only one with a negative exponent? X. So only x is moving to the denominator. Y is staying put because y's exponent is positive. So here I have y to the 3/4 over x to the 2/4. At this point, can I leave it as it is? No, because doesn't a fractional exponent represent a radical? And I can't leave a radical in the denominator. How many people like changing to a radical and then rationalizing? How many people like rationalizing with a fraction with the fractions? How many people like the radical? Okay, I'll show both ways. I'll do the fractions first. So here I have x to the 2/4. What's the closest whole number to 2/4? Wouldn't it be 4/4? So I have to multiply by x to the 2/4 to get 4/4. So in our denominator, I have x to the 2/4 times x to the 2/4, which is x to the 4/4, which is just x. And then in my numerator, I'm now going to change to radical, the fourth root of y to the third, x to the second. Would it have been okay if I wrote x to the second, then y to the third? Yeah, multiplication's commutative. It doesn't matter. So that's how we would have rationalized using exponential. Now, if I changed it to radical, so go back here, we would have had the fourth root of y to the third over the fourth root of x squared. Okay, so now in order to rationalize, I have an index of 4 and I have 2 x's. How many more x's do I need to make a grouping of 4? 2 more. So we're going to multiply by the 4th root of x squared, top and bottom. So in my denominator, I get an x because I'm going to have a group of 4 x's, so one will get pulled out. And in my numerator, same thing as before, I get the 4th root of y to the 3rd x squared. Once again, do I care how you rationalize? No, I don't care. All right, the last thing I need to show you is adding and subtracting for today. The 4th root of 4 minus the square root of 2. In order to add or subtract, there's a bunch of things I need. Not only do I need the same index, but what else do I need? The same radicand, right? I need the same index and I need the same radicand. Right now, my biggest concern is that I have different indexes. So I'm going to change this to exponential. So this is going to be 4 raised to the 1/4 power minus 2 raised to the 1/2 power. Now, I can change the 1/2 to an index of 4. We can do that, right? But even if I change that 1/2 into an index of 4, will my bases or my radicand still be different? So then I have to ask myself, is there any way possible to change this 4 into a base of 2? Yeah, how can I change 4 into a base of 2? Anish?
Taking like 2 to the square, 2 to the square.
You got it. So we change this base of 4 into 2 squared raised to the 1/4. And then see from there. So now when I have 2 to the 2nd raised to the 1/4, I have 2 to the 2/4 minus 2 to the 1/2. So now I can change this 1/2 to a 2/4, but what would be smarter to do? Change this 2/4 to a 1/2. I can reduce it so it's smaller. So now I'm going to have 2 to the 1/2 minus 2 to a 1/2. What happens when you subtract the same quantity? It's 0. When you subtract the same quantity, it is 0. So we end up with a 0 here. All right, this is where we stop.